Okay, here we go. Linear graphs, practice test number 1. So we see an equation and we're going to graph it. We're going to start first with our y-intercept. Then we're going to use the slope. So let's see, the y-intercept was 4, the slope is 2/3. We're going to use the slope to help us get to the next point, up 2 over 1, 2, 3. We'll connect these 2 points, and we're done. With the next one, we see something's missing. So I encourage you to rewrite the problem, but put +0 because the y-intercept is 0. Our slope is 3/5, so that means up 3, 1, 2, 3, over 1, 2, 3, 4, 5. Connect your 2 points, and you're done. The next one, it doesn't look like something's missing, but when we look for the slope, we see that there's not a number in front of the x. We ask ourselves, how many x's do we see? We see 1 x. And that helps us to see that the y-intercept is 6 and that the slope is 1. Once again, if we have a whole number or an integer, we put a 1 underneath because that reminds us, rise up 1, run 1. And we could do a couple more if we wanted to and connect those. And we're done. Here, a lot is missing. We've got x equals -2. You can decide to go ahead and do a table with x is equal to -2 and y being 0, 1, 2. And when you graph that, you've got a point here, you've got a point here, you've got a point here, and up and down. And you're done, except for to ask for the slope. When we've got a line that's straight up and down, it's a vertical line, we say that the slope is undefined. So we could write it out, or we could just say UND. The x-intercept is right here at -2. Do we have a y-intercept? Do we see it? Does this line ever cross the y-axis? Nope, it's never going to take a turn and cross the y-axis, so we'll say none. There's not a y-intercept. Okay, with the next one, y equals 5. You can do this a couple different ways. A lot of people know that y equals 5 looks like this. Or you could go ahead and write what's missing. The x isn't there because there are 0 x's. If you rewrite it this way, it's easy to see that the y-intercept is 5. The slope is 0. The x-intercept, are we ever going to have this line curve and go through the x-axis? Nope. That is not. There's none. This next one, we've got the y-intercept is -3. We'll put a dot there. Our slope is down 4. Don't forget to run 1. So it's down 4. 1, 2, 3, 4 over 1. Draw that line. Oh, that was really bad. Let me try again. All right, let's try again. Let's try to hit both those points. Not bad. Hopefully you're using your ruler at home. On the test, we'll definitely use the ruler. All right, so now we've got the type of graphs or the type of equations where we've got to move some things around. The first thing we're going to do is distribute the 3. So we'll carry down the 1, y minus 1. We'll say 3 times x is 3x. And then 3 times -3 is -9. We're almost done. We're going to add the 1. -9 plus 1 is -8. So we know that the y-intercept, if I have a -8. So I'm going to have to bring my graph down a little bit so I can have a -8. So here we go. Our y-intercept is -8. And our slope is 3. So that means 3 over 1. So we'll go up 1, 2, 3 over 1. Connect those 2 points. This next one, we're going to do the same thing. We're going to rearrange. First, we're going to do the distributive property. Well, actually, first we bring down the y plus 8. We distribute. 2 times x is 2x. 2 times 6 is 12. Let's subtract 8 from both sides. If you need more of a lesson on how to do these, besides I'm going pretty quickly, you may want to check out some of our flip lessons that talked about how to graph these. So now we know that our y-intercept is 4. We're going to graph it. And our slope is 2. Same thing saying 2 over 1, right? We're going to go up 2 over 1. So we are showing how wonderfully we can graph given an equation. So here's an equation in standard form, and so we're going to do the cover-up method. And so how we did it in class is we'd always set up a table, and we'd say, what happens when x is equal to 0, and what happens when y is equal to 0? Well, when x is equal to 0, 2 times 0 is 0. It goes away. So what am I left with? I'm left with negative 3y equals 24. I'm going to go ahead and divide both sides by negative 3, and I get y equals negative 8. Then, let's see what happens when y is 0. When y is 0, negative 3 times 0 is 0. That goes away, and I'm left with 2x equals 24. Divide both sides by 2, and we get x equals 12. All right, so let's see. How do we graph this? This shows us that y is equal to negative 8, right? When x is equal to 0, we go to the y-axis. We put a dot on negative 8. This shows us that x is equal to 12. Oh man, I'm going to have to extend this. 11, 12, it's okay, we can manage. Then we're going to connect those 2 points. There we go. Not bad for not having an eraser, or not having a ruler or an eraser. All right, so let's do the next one. It's also a cover-up, so we're going to do, oh, wait a second. They asked for the x-intercept and y-intercept. We're going to want to go ahead and put that the x-intercept is 12 and the y-intercept is negative 8. Let's move on. We're going to do the same thing. We're going to use the cover-up method, but we're going to use a table to help us keep track of our work. If x is equal to 0, negative 2 times 0 is 0. That's gone. And I have 6y equals 12 left. Divide both sides by 6, and I get that y is equal to 2. When y is equal to 0, 6 times 0 is 0. That goes away. And all I have left is negative 2x equals 12. Divide both sides by negative 2. X equals negative 6. So this part tells me that one point is negative 6, 0, right? That's going to be on the x-axis. So that's my x-intercept. And then this part tells me 0, 2 is the point right here. That's my y-intercept is 2. So really, so far, if we could just go back over real quickly. You know, when you're taking the test, you just need to be aware of when to use y equals mx plus b, right? Using y equals mx plus b on these 2 pages. When to, on these 2 problems, when to notice that something's missing and write it in. Same thing here. These both have something missing. Well, this one just has the 1 missing. Whenever we have x equals to negative 2, we're going to put negative 2 for x in the table. So just be so good at practicing these that when you see them on the test, you know that you're using y equals mx plus b, and you're filling in things when you need to. And when you get to these on the test, just know that your goal is to get them in y equals mx plus b form. See how we did that for both this and this? We distributed and we rearranged and we got there. Then we did the cover-up method, and so your job when you're taking the test is to notice when the x and the y are on the same side and there's just a number on the other side of the equal sign. That's standard form, and that's when you need to use the cover-up method. All right, so now we are all the way to the context, and we're almost done. Your parents deposit $80 into an account for your morning coffee. You get a frozen mocha each morning that costs $5, including tax. The equation y equals negative 5x plus 80 represents the amount of money in your coffee account on any given day. So it tells us what we're dealing with, right? Amount of money and day. So we can be very specific. We can just put day and money. We could put money in our account. We don't have to. And then we're going to notice something. We need to include an 80 on the y-axis. So obviously we're not going to go up by 1s, right? But we could, and even going up by 2s isn't going to work. Going up by 10s would work. Going up by 5s I think would work. And so we're going to look at a hint. We're going to look at the slope. The slope is going down 5 over 1, down 5 over 1. If we go ahead and label our y-axis going up by 5s, hopefully we get to 80. No! We're going to keep going. We're going to extend this. 65, 70, 75, 80. Woo! There it is. Sorry we had to extend it into the words, but we got to do what we got to do. All right, as far as days, just like in practice in class, we can just do 1 and 2 and 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so let's see what's happening here. We can look at this equation right here. We see that it's in y equals mx plus b form, right? Where that's the y-intercept. So we're going to put that at 80. And then our slope is down 5 over 1. So down 5 over 1, down 5 over 1, down 5 over 1. I want to put little dots so then you can kind of keep up with me. Down 5 over 1, down 5 over 1. Finally, down 5 over 1. Finally, we're on the graph. Down 5 over 1, down 5 over 1, down 5 over 1. All right, this is problematic, isn't it? And it's a good thing that I did it this way. Given the numbers that were given, we're going to have to extend the x-axis too. So let's see if we can finally make it down to the x-intercept. Knowing what I know right now, I might have wanted to do the, so that's 12, 13, 14, 15. Let's see if we can get there. I might have wanted to do the y-axis by tens. Down 5 over 1, down 5 over 1, down 5 over 1, down 5 over 1 on the 16th day. So hopefully you're okay with getting a little bit flexible here. So y-intercept is 80. And what does that mean? What does our y-intercept mean in this problem? Well, they tell us. Your parents deposited $80 into an account. So you have a choice. You could use in the beginning or at the start or initially. Any of those words you can use. So I like in the beginning. In the beginning, you had $80 in your account. So you don't have to put those exact words. You can use something different, but just show that you know what 80 means. And so then, never even connected my line, did I? I get on you guys about doing dots and not connecting them. Okay, that's supposed to be on 16. And then it asks for the x-intercept. Well, the x-intercept is down there at 16. And what does that mean? What happens on the 16th day? That's right, we finally run out of money. So you can say on the 16th day, there's no more money. You have $0. You have no money in the account. Anything, right? Anything that makes sense, that basically conveys that all the money is gone in the account. Okay, so even though we had to extend this, if this happens on the test, I have a feeling the test probably has numbers where we won't have to do such an extension. But if it happens, we can do it. We can extend up. Or we could have just done the money up by tens, and then it would have looked a little bit different. All right, let's go to the next one. You want to join a music service. Data phi's cost model is y equals 5x plus 120. So that's one graph, one equation we're going to graph. And then Tandora's cost model is y equals 10x plus 20. All right, for both models, x is the number of months and y is the amount of money you've spent. So we're going to go ahead and label the x-axis months and the y-axis money. And we're going to think about...
Time is almost 4 o'clock. You're riding the 410 bus.
Okay, so that's the bus announcement. Okay, so what we're going to do is we're going to notice something. We need to include a 120 on this y-axis. If I go up by 5s, I'm not going to make it, am I? I'm going to have to go up by 10s. So, and 10, 20, 30, 40, I wish I could write smaller, 50, 60, 70, 80, 90, 100. All right, so you're setting up your chart, or you probably already have it set up. I'm just catching up with you. So we needed to go up by 10, so we're going to have to get a little creative with when the slope is 5. Okay, and then the months, we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and so here we go. We're going to go ahead and do Datifies first. So I'm going to do that in blue. So Datify has a y-intercept of 120, and we're going to go up 5 over 1, up 5 over 1. So I want you to notice what we're going to do. We're going to have to go up halfway between 120 and 130, right? So up halfway, so that's 5 over 1. Up 5 over 1. You see what I'm doing? We're going to continue that so we get an idea of what this line looks like. All right, we're going to connect our dots. And let's go ahead and switch to Tandoras. I'm going to do Tandoras in red. The y-intercept is 20, so it's way down here. And the slope is 10, so up 10 over 1. So we can already tell that this red line, Tandoras, is much steeper. Look how it's climbing so much faster. In fact, it's twice as steep, isn't it? Pretty soon, if we had more of the graph, it would catch it. Oh, man. Okay, if we had a bigger graph, we would see that these two lines would intersect, right? Let's extend the blue line, that eventually, right, they're going to intersect each other. So what does the y-intercept mean? Well, with both of these, it really represents the initial cost of the music services. So we're just going to put initial cost. And then which service has a steeper line? Well, we can just tell by when we were graphing it, that Tandoras has a much steeper graph. And it says, what does that mean in the context of the situation? Well, that means that the price goes up faster. All right, how much would you have spent with each music service after 12 months? What we could do with this one, sometimes we can do it and sometimes we can't, is we can actually look at the graph and see what's going on at 12 months. So let's see. The red is Tandoras, so Tandoras is, looks like 140. And then let's see if we can tell Datifies. Let's see, we'd be going, let's see, up there, over, up, over, up, over. We'd be right there on 180. Okay, so at that point, Datify is still more expensive because it started out so high. So what if you couldn't tell the answer from the graph? Well, what you'd have to do is do it algebraically. So what you would do is take, let's try to use it, let's pick up a totally different color. Let's go ahead and, that's kind of pretty. All right, let's go ahead and use this equation for Datify. And when we see x, we're going to plug in a 12. So 5 times 12 is 60. 60 plus 120 is 180. So we get the same answer. You can either do it graphically if it's available to you, but sometimes our graphs might not be as clear, and we'll have to do it algebraically. And then let's pick another color to do. Let's do orange. So let's do Tandoras. So we would do the same thing. We would go ahead and look at Tandoras equation, and when we see x, we're going to plug in a 12. So 120 plus 20 is 140. So you can get your answer either way. It's easier to use the graph if the graph is good enough and clear enough that you can get your answer from it. If not, you're going to have to plug in and find it this way. All right, that's about how long your test will be. Thank you for joining me, and I look forward to seeing you in class where we will do more practice.